Mars, our neighboring planet, is a place of stark beauty and fascinating secrets. Mars was once an Earth-like environment with flowing rivers, enormous lakes, and probably even oceans, but now it is a frigid, lonely wasteland. Understanding how Mars evolved from a potentially livable world to the desolate planet we know today requires diving into its geology and atmospheric history. The early Martian paradise. Billions of years ago, Mars was much warmer and wetter. Geological evidence, such as valley networks and outflow canals, indicate that liquid water formerly flowed over its surface. This suggests a thicker atmosphere capable of supporting a hydrological cycle like Earth's. Ancient Mars most likely possessed a magnetic field created by a dynamo effect in its molten core to shield its atmosphere from solar winds. The disappearance of the magnetic field. One of the most significant events in Mars evolution was the disappearance of its magnetic field. Scientists assume that roughly 4 billion years ago, Mars' core cooled sufficiently to end the dynamo effect. Without a magnetic barrier, the solar wind, a stream of charged particles from the sun, started to deplete Mars' atmosphere. This process, witnessed firsthand by NASA's MAVEN probe, resulted in a steady thinning of the atmosphere. The atmospheric collapse. As the atmosphere decreased, Mars' ability to retain heat waned, resulting in a sharp drop in surface temperatures. The decrease of air pressure also meant that liquid water could no longer exist on the surface, either evaporating into space or freezing into the Earth. The planet's climate changed from a reasonably warm and rainy environment to the cold, dry circumstances we have today. Geological activity. Mars likewise saw a decrease in volcanic activity. Massive volcanic landforms such as Olympus Mons and Tharsis Montes indicate a time of strong volcanic activity, which may have helped sustain a thicker atmosphere by releasing gases. However, when the planet's core cooled, volcanic activity decreased, adding to the atmospheric fall. The role of water. Water had an important part in forming early Mars, but when circumstances changed, much of the water disappeared. Some water became trapped in polar ice caps and underground in the form of permafrost. NASA's Mars rovers and orbiters discovered evidence of old lake basins and river valleys, indicating that water previously flowed freely. Today, water on Mars is predominantly ice, with occasional subterranean brines that may sustain microbial life. Dust and climate change. Mars' iconic dust storms also influence its climate. These storms may cover the whole globe, obscuring sunlight and creating temperature swings. Over time, dust has helped to redistribute water, with some ice being buried behind layers of dust, making it more solid but less accessible. Implications of human exploration. Understanding how Mars lost habitability offers critical insights for future human exploration. Any expedition to Mars will face problems such as radiation exposure from the thin atmosphere and the absence of a magnetic field. Furthermore, access to water resources will be critical for human survival on Mars. Mars' transformation from a potentially habitable planet to a desolate globe is a tale of cosmic forces and planetary development. The loss of its magnetic field, atmospheric stripping by solar winds, and geological changes have all led to its current condition. As we continue to investigate Mars, we learn not just about its history, but also about how we may better understand and safeguard our own planet. The destruction of the red planet serves as a reminder of the dynamic and sometimes fragile character of planetary ecosystems, providing a window into the past as well as a guidance for the future of space travel.